So in today's session, we will discuss regarding the slowly changing dimension. So we will take up an example of very few records we will take up. Rather than taking more records and not to understand. So what I mean to say here is I will take few records for the slowly changing dimension to explain, and so we'll proceed from there. So in previous session, we have discussed what is a slowly changing dimension. So how actually it is going to be worked. So what are the scenarios in which we are going to use the table comparison and the map operation. So that is what actually we have understand in the slowly changing dimension type 1 and 2 and 0. So let's have a recap of what actually we have discussed in the previous session. Let me open my PPT. So I have pulled my PPT here. Yes, I'm sharing my screen. I hope you're able to see my screen now. So in previous session, we have discussed something called as an operation codes. So the operation codes in the transformations are very important, and so each and every transformation. So whenever they are producing records or whenever they are leaving the records from their output schema, they will be mainly assigning these operational codes to the records. There is something called as a normal operation code, insert operation code, delete and update. These are all the operation codes that will be assigned to the user. I mean to say they are assigned to the records. If any records coming out of a query transformation, so all are populated or flagged with the normal flag. So remember that whatever the operation codes that I am trying to show you, these operation codes won't be visible for you. Okay, these operations are by the BODS engine. These operation codes will be assigned to the records behind the screens. Behind the screens, so what actually happens is, so the operation codes are released by the BODS. Depends upon the operation codes. If you want to compare and if you want to delete or if you want to update, so all these operations will be taken care by the respective transformations. So if you take an example of a query transformation, if any records coming out of a query transformation, you can say that all the records are populated, or all the records are flagged, are coded with the normal flag. That is the basic example of the normal flag. And whenever we are trying to create a new row in the target system, then all the flags will be set to normal. That is one thing by default. So let us take an example that if you are loading any particular records into the target system without comparing, if you say that there are some records are coming from the source system, like in the form of a delta. If any records are coming into the target system as a form of a delta, I mean it's the last 1 day data you want to have every day. Only previous data you want to load it. Only last the 5 days of data you want to load it in the target system. So that is where actually, so you are going to understand or you are going to say that those records are flagged with normal operation code. So similarly, if we have an insert, so let us take an example that the rows that are generated are gone through from the table comparison, so they will be called as an insert flag. So that's the reason why if anybody asks you what are the operation codes the table comparison will generate, so your answer should be by default the table comparison will generate an insert and update. So it depends upon the availability. If you want to insert records as an insert, or else if you want to insert records into delete, or else if you want to update records as an insert. So it all depends upon your requirement. And also remember that normally with the table comparison, the map operation will be used. The combination is very important. If anybody asks you what is the transformation that follows the table comparison, is the map operation. That's what we have to understand. So after that, if you see here in the insert the statement here, the new row, whenever we are trying to load using a table comparison, then the record will be flagged with an insert flag. That is one thing. And the map operation can produce rows flagged as an insert. See here, map operation also produce a insert flag tables. So similarly, we have history preserving transformation, key generation transformations. They will accept the insert flagged records. So that is what actually you have to understand here. So you have to understand what are the transformations, what they release, and what they accept. That is one thing you have to understand. And similarly, we have a delete flag. The delete flag also it is raised by the table comparison. And these delete flags also consumed by the map operation. The delete flags will be generated from the table comparison. So all these things. Similarly, history preserving transformation also will take this what you call as accept the delete flags. Similarly, if we have an update, so what actually the update will happen? The update will happen something like that. Rows can be flagged as an update by the table comparison. As I mentioned previously, the rows generated by the table comparison are called as or flagged with an update flag. So whenever the records are generated or flagged with an update code, operation code, and those will be consumed by the history preserving transformation or else the map operation. And also you have to understand, if anybody asks you, so for history preserving transformation, what are the equivalent transform you can compare? Then you can say that one history preserving transformation is equal to 2 map operations. That we will see later on. So that is the basic operation codes, how actually the BODS is going to release and how actually the BODS is going to generate. So now we will see that still now what are the operation codes are now we have seen. Now we will see that what are the transforms actually we normally deal with the operation codes actively. Then we will first the transformations that comes to your mind is the table comparison and the map operation. When I say table comparison, as I mentioned earlier, these are all the parameters that needs to be passed that we have gone through in previous session. So in order to understand the table comparison further, so please try to identify this particular example. So this is what your source and this is what your target. So please what you call as the compare the source with the target. Then use a table comparison, then load it into the target system. That is what so we are understanding. So I'm comparing source with the target 1001, 1007, 1009 as an employee code. So as mentioned previously, so the records will compare with the primary key. So it will take 1001 from the source system, and that 1001 will be compared with 1001 of target system. Then if it is exists, then the table comparison knows that okay, the record is already exists. Now I have to look for an update. What record got updated? That is what the statement here. See here 1001, it is already there. Then it will compare on the remaining records we have, remaining columns we have. What are the remaining columns we have? We have the remaining column and the last name. Okay, it will compare with the last name. Okay, nothing got changed. Okay, that is fine. Leave the record as it is. Then 1001 is compared with 1009. So as I mentioned previously, the 1001 is equal to 1001. Then it goes for an update statement. If I say that 1009, okay, so 1001 is in the source table is not equal to 1009 in the target table. Then the condition will fail. Then it will go to the 1007. Okay, it will compare to the 1007. Okay, it is not correct. So the condition will fail. 1009, the condition fails because it couldn't able to identify 1007 at all in the target system. Then it will raise an insert flag. That is what you have to understand. Then this is the output coming out of a transformation. See here, what actually this table comparison is saying that the table comparison getting the record with a normal operation code. But whenever the primary keys in the source and primary keys in the target system are getting compared, and whenever they have realized that they don't have any what you call as 1007 record is there, they don't have any record in the target system, then the table comparison will write an insert. That insert, the statement, with the help of an insert statement, the record will get, what you call as will get updated, will get inserted into the target system. That is what actually happened there. That is from the insert standpoint. Now, so we will see like something called an input data set and comparison table. So again, like we're comparing with 1001 in the source and 1001 in the target. Similarly, 1001 with 1009. So it says that 1001 is there in the source and even the 1001 is there in the target system. So whenever it is comparing the rank between source to the target, it is realized that, okay, instead of 81, it is there in 80. So what I have to do? I have to write an update statement for that rank, something like that. The table comparison only generates the code. Whether you really want to update, whether you really want to insert, it's all your wish. It only says that, depends upon the comparison of the primary keys, it will simply say that whether it is inserted record or deleted record. Only that information will be provided to you there. Similarly, the delete statement. Normally what happens, so if we have a source record and in the target, if you have a source record, but if you don't have a target record, or else if you have a target record and if you don't have a source record, and if you want to delete that particular record from the target system, in that instances, it will generate a delete statement. Like this. So these are all the different methods of generation of an operation code using table comparison. So what actually map operation will do, so whatever the operation codes raised by the table comparison, those operation codes will be executed by the map operation. So let us take an example that.
Ankur?
Yes, please.
I have a question back on the Power page here.
Yes, please.
Scroll back. You talked about it doing an update. Yeah, back to the prior one. Here, yeah, the update there. You talked about it having to code something for the rank column. In this case here. Why
Right.
doesn't it just, since it's a change,
Yes.
why doesn't it just go and replace all the columns? Well, why would you have to code, it goes and finds that column's different. Why not just overlay whatever's there?
Okay, got your point. See here, so if you take an example of 1001 is a primary key, that 1001 in the source will get compared with 1001 in the target. Okay? Okay. 1001 in the source is equal to 1001 in the target. Then it will compare on the rank, or else it will compare on the remaining fields you have. Once the primary key of source 1 is equal to once the primary key of the target, then it will compare the remaining columns. So getting my point, what I mean to say here? If compares rank value 81 with 80, it realizes that, okay, so these values are not same. So what I have to do? I have to write a statement called update.
It won't do that for you with the columns that are different. It won't go and replace them automatically on the update.
Yeah, so it is not going to replace automatically. So what it will do is, it is going to write an update flag, update code. It is going to write an update code actually. Okay, when I say update code, it will tell to the other transformations, hey, I have identified a different value in the rank. Please go ahead and update. Only that information will be given to the downstream transformations by the table comparison. Getting my point?
Yeah, well, say for example, there's 2 columns or 3 columns that are different. Are you going to have to code each of those update columns? I don't understand.
Right. Let us take an example that once the employee ID in the source is equal to once the employee ID in the target, then you will say to the table comparison saying that please compare 2 or 3 columns. What are the columns you have? Let us take an example that maybe you have 30 columns. Maybe I'm interested only in the 2 columns to compare. Getting my point, what I meant to say? Let us take an example that I have an employee 1001 in the source and the target. If the 101 is equal to in the target system, then I will say that, okay, once the primary keys exist in both the systems, then I can assume that there is an existing record. If it is an existing record, I will tell to the table comparison saying that, so please compare on 2-3 columns. That can be on company name, that can be on the contact name, that can be on the company address, something like that. Getting my point?
Okay, I guess they let you be more selective. I guess I would have thought they would code it so it did it automatically, the system. But that's enough of that. Yeah.
No, the table comparison, yeah.
Refresh copy, so you know you're in sync. But you want it to be able to do selective. This column, yes, that column, no, even though it's different. Apparently.
Okay. So you got my point? What I meant to say?
Yeah. I just thought it would be more of a synchronization, but it's not really interested in making everything the same. Just maybe separate.
Right. It is not, not the transformation. It is going to make it everything in sync.
Like a replica type thing. Yeah.
Right. Yeah, there are a lot of scenarios actually. So if you want, you can make it sync. That is different. So I'm saying that table comparison will raise an update flag. If you want to really an update, yes, please update. Then that will be a sync, right? But if table comparison has raised an update, and if you don't want to make it sync, but if you want to make it like another record, then that will become your history preserving. Getting my point? What I mean to say? Let us take an example that 1001 is an 81. So I think I have to go to the example, what we have discussed previously. See here, what I mean to say here. So we don't have any records in the target system. So what I'm taking is I'm taking all the records from here and loading into the target system. Let us take an example here. Okay. So now See, please observe carefully. So let us take an example that the Watson has changed his address from UK to India. Okay, so 1001 will get compared, and I'm saying that please compare on the employee address. That is what I have mentioned to the table comparison. If initially, please make sure that if the primary key is there or not. So 1001 it gets compared with 1001. Once this is equal to this, as I mentioned, please compare an employee address. US is equal to US. Okay, nothing got changed. Then 1001 is not equal to 2222. Condition failed. 10001 is not equal to 3333. The condition failure. Then 2222 is equal to 1001. No. Similarly, 2222 is there. But the India, the employee ID of the 2222 is not changed. So it remains the same. And it says that 3333 is there. And the condition fails with 1111, 2222, and 3333. It says that okay, so I have the same record, but when compare the employee address and the source and the employee address in the target system, it says that India and UK, two different. Now the table comparison says that I am raising an update flag here. Okay, but if you want to update into India or you want to load another record, it's up to you. So getting my point on what I'm trying to refer here?
Okay, yeah, it just works a little different than I expected. Like I thought every column that you compared on that it would go ahead and automatically update it. Like otherwise, why bother comparing? But
right.
That's okay.
Yeah. Right, so the table comparison will require, if you want to perform any particular an update or insert, and the table comparison also will help you to perform if you want to preserve any history. So during that scenarios, normally you will go for the table comparison. So if you want to automatically update, then there is no need to have any particular the table comparison at all. Okay. So if you take an example of a slowly changing dimension 0, what actually slowly changing dimension is doing? So whatever you have in the source, you will be in sync with the target, because that will be always a truncate and load. Then if it is a truncate and load, obviously everything will be in the sync, right? So that is what actually happens in slowly changing dimension 0. But the beauty of the slowly changing dimension concept is you have to preserve the history, because that is where actually the data warehousing is, gives us an advantage. If you want to preserve the history, yes, you can preserve the history and you can take a decision for the future enhancements or future investments. That's where actually all these things will come up. Update code or insert code, or so whatever you have. So now I think we have to jump on to the practicals, then you will understand better. So map operation, the map operation, as I mentioned earlier, whatever the statement has raised by the table comparison or codes raised by the table comparison, those codes will be manipulated using map operation. That we will see that how actually it is going to manipulate and on everything. So now, I will be logging into the server. Now I will be defining one by one the slowly changing dimension. So JB SCD SCD0 underscore. So now out of these three, you are taking up the first one. So you can have a workflow. You don't require, it's not required, it is not mandatory that we need to have a workflow in the job. Data flow. And this is my source records I have. I'm just taking a few records so that you will understand much better. Okay. So now I will be creating a file format. So that is a .csv file. So if it is a .csv file, which file format you have to create? You have to create the standard file format, what we have created earlier for an Excel sheet. So similarly, because this is a .csv file, so what I'm going to do? So I'm going to create a file format. Remember that for Excel sheet, we need to create an Excel file format. But for a .csv file, you have to create a file format. Even for the .text file also, you have to create the same. FF, so file format, SCD. You can say that SCD, not a problem. You can say all. In the all SCD2 I have. Okay. So you can say that here, the skip row header from this so that it will becomes my header. Yes. That's it. Okay. Save and close. Simply drag and drop. Query transformation. So I'm simply executing the job here. So 91 records got loaded. Okay. Some nulls we have in between. And these are the records we have actually. Okay. So maybe we have to clean those records. So I've removed some fields here for our understanding purpose. I will execute the job once again. Okay, the customer ID, company name, contact name, address, and city. This is information we got. If any records are changed in the source system, so let us take an example that if the contact name got changed for that company name, so for ALFKI company code, Alfred Photoscity, so maybe instead of Maria, maybe someone called Anderson. The contact name got changed, maybe. Okay, so maybe one of the record got deleted. Let us take an example. So one of the record got changed. Something like this. So what we did, actually, we did one update and we did one delete actually. So when we are talking about a slowly changing dimension 0, then as I mentioned previously, the slowly changing dimension 0 always preserves the current information. Okay, so now when I right click and execute, see here for ALFKA Anderson, and whatever the record got deleted, that is not there. So this is where actually I think the Dawn is referring to sync. So in order to perform the sync, so you don't have to use any table comparison, you don't have to use any map operation, you don't have to do any history preserving or case generation, etc. The slowly changing dimension by definition is, so you have to preserve the history. You have to identify the behavior of the dimension when compared to the measures or whatever it is. So that's the reason why it is called as a slowly changing dimension. So when we are talking about a slowly changing dimension, the main purpose of slowly changing dimension is to preserve your history. So if you want to make the source to the target, if you want to sync the source records to the target records, then you don't have to perform anything. You don't have to do any comparison. So simply you can do a truncate and load. Truncate and load. When I say truncate and load, what you can do? So you can always say in the target properties, you can always say that check this checkbox. Check this checkbox. So automatically every time whenever we are trying to load into the target system, the records gets deleted and it will become say full load. Every time it is a full load. So every time it is a full load means it is a truncate and load and it is called a slowly changing dimension 0. That's it. Very straightforward, very simple. And some companies and even so whenever we are going to create any particular the project in general, we will use a script for that. What we will do is we will try to write a the SQL function, and the SQL function we will say that whatever may be the target table that you are referring to. So for that particular target table, there is our so this is what also target underscore the SQL server underscore DB, and you would write a statement saying that truncate table. What is the table name? SCD1. That's it. So that is what you're going to do. If you have any specific schema, you can also say that DBO dot. verify it is a valid. So that is also you can do that. Something like that. You can remove this checkbox and you can place that script and the starting of your data flow. Then you can execute the job. The same thing will happen. Nothing will be changed. Okay. So this is how actually the slowly changing dimension 0 will get implemented. Okay. So you can also say that one more. You can define a primary key. Okay. So you can execute the job once again like this. Okay, because it is truncated and load, you should not get any problem. Okay. And this is a very straightforward, slowly changing a dimension 0. So now we will take up the slowly changing dimension 1. But before that, so did you understand that? Because the slowly changing dimension is very normal. It is simply a full load. In general, if it is a full load and if it is no change in the target system, then it will be called as a slowly changing dimension 0, because we are not preserving anything or else we are deleting anything here. So this is an example of a slowly changing dimension 0. Now we will take up an example of a slowly changing dimension 1 actually. So JB underscore SCD underscore 1 actually, you can say that. So this is one data flow or one workflow, sorry, one job I have created. Now I have created one data flow. Now use the same file format what we have used the previously. Drag and drop. Oh, it has gone to this location. So simply drag and drop. If you don't want to use query transformation, also that is fine, not a problem actually. Okay, and then perform a normal operation. I mean to say that the comparison. So I will take up a table comparison like this. Like this. Okay, see here. Now, so what you can do is you can define this one. This is as a primary key. And in the previous example, whatever the table that we have used it, I will make that table as a permanent table so that I can compare. The permanent table, I did a permanent table there. Now I will go to the slowly changing dimension 0. I'm trying to compare with the target records. What are the target records I have? I am comparing actually. I'm comparing this table. And see here, this is a records or columns coming from the source. This is the columns that I already have in the target. Okay, I'm trying to compare these two, if any change in the records are happening there or not. something like that. So now we need to have one primary key actually, that is mandatory, because you have to compare on the primary key between the source and the target. And now what you want to compare? You want to compare on maybe address. You also need to what do you call as on the city you want to compare. So all these things that you can do. Okay. Then normally the table comparison will be followed by a map operation in general. See here, it is very important. If the table comparison has raised an update code, then map operation says that if you want to update in the target, or else you want to do a insert, or else you want to delete, or you want to discard. So that things will be asked by the map operation. If you want to preserve the history, then you can say that update. Whenever any record got updated, that updated record should be inserted. That is what you're going to say. If any particular record is inserted, yes, please insert in the target system. That is what we are going to say in general. Okay. So if any record got changed in the source system, that has to be updated. If it is not updated, if it is not inserted, please keep as it is. You don't have to worry at all. So then what I do is I will go to the data store. I will go to the target underscore SQL Server underscore DB, go to the tables and simply drag and drop the target table and simply map it.
Venkat,
Yes.
sorry, I got a question.
Yes, please.
While you update the record, basically it updates the parent record, right? I mean, it does not create two records, right?
I didn't get you. Can you repeat once again, please?
Question is, let us say there is employee ID something one in my source, and if I using here update in my map operation, then as per the condition, it will update this employee ID to a different value. But after the output will be the updated value. I cannot see both one and the new updated value, right?
Right.
So then how the history is going to be maintained here?
No, that's what we are trying to discuss, right? Okay. That's what I'm trying to give you a scenario where if it is an updated record,
okay.
If it is an updated record, if I'm going to update in the target system, there is no history. That's what I'm keep on telling. Okay? If it is an updated record and if you do an insert, then it will become an latest record plus previous record.
Previous record. Yeah, understood.
Yes, that is what. That won't be changed at all. Don't worry. Okay?
Understood. Yep. Okay. Thanks.
Execute. Now let us see whether it is rising any flag or not. Whether what actually is going to happen, what it is going to do, and all and everything. So we have, see here, it says that table comparison didn't rise anything. See here, 0 records from the table comparison standpoint. So getting my point? See here, from the table comparison standpoint, it didn't compare anything. It didn't release anything, I mean to say. Even though it has compared 6 records in the source and 6 records with the target system, it didn't identify any updated records or didn't identify any inserted records. So that is what it says. Let us take an example that I'm going to insert one record. So you guys are getting my point, Don. So you are getting my point. What we are trying to achieve here. Something called as.
Okay.
So I've inserted one value. Okay. So I have CEO, the difference between the discard and delete. Okay. So when I say discard means don't do anything. Don't do anything. Discard means just ignore it. Whatever is coming, ignore it. Whether it is an update, please ignore it. Don't do anything. Whether it is a insert, please ignore it. Please don't do anything. I mean to say, if it is an update or if it is an insert, don't affect anything in the target system. So that is what I actually meant by a discard. Okay. When I say delete, then what actually happens, if you don't have a record in the source system and if you have a record in the target system, then identify those and delete those. That is what actually happens from the delete standpoint. So that is the basic difference. Now I have inserted one. Let us see what actually happens here. See here. It says that I have added one more record. Okay. In order to understand much better, I will perform one more change. What is a change? I will insert one more. One. Okay, I have inserted one more record. And now I will run the job in debug mode so that you will understand much better. Right click and execute. Rather than doing an execute, right click and perform the start debug. Okay, now please observe how actually it is rising a flags. Okay, so after the file format, yeah, you are able to see the 8 records. That is fine. After the query, yes, you are able to see the 8 records. After the table comparison, see table comparison, what it is trying to do. So that is where actually the change will happen. Similarly, after operation code, what is happening there? It is trying to understand. So running the debug mode is very, very important. So you will understand much better with this particular debug mode. So normally running the job in debug mode, what I mean to say is it will help you a lot in identifying the issue, where actually the issue is there. Even if you have identified, or else if you have narrow down the issue, in order to perform all these operations, so you need to have a that particular the start debug mode. If you run the start debug mode, so you will understand where actually we are going wrong and what actually the records are coming without after each and every transformation. That is what actually happens here. So now, so we have gone through the table comparison and the map operation. So what is my request would be for you guys is, I will send you the sample and I will send you the, all these, whatever the job that we have discussed till now, everything I'm going to send you in an email or in the training blog. I'm going to update. So my request would be, please change some records in the source system, and so please change these operation codes. So please make it like an update, insert one time. I mean to say, if any record got updated, you please make them insert. so that you will get a preserve the history and the current, both you will get it. Similarly, insert as an insert, that is fine, but update or also make it as an insert. So if anything got deleted, so please delete once again. Okay, so please do the manipulations as required. So because I want to take up the different scenarios, but my request would be, so rather than doing all alone, we have another beautiful example, that is with the slowly changing dimension 2 actually. Okay, so my request would be, so I will send you the sample file. So please have a recorded session, and so please take up all your activities of so changing the manipulations and all and everything. If you want to insert new record, then make it an update as an insert. That is a very important point you have to understand. Then you will come to know what are the issues are coming up. Okay, so I will just leave it for you guys, this particular part only, because it is very, very important to play a major role in your life. So in the BODS career, that's the reason why. So please practice and come up your doubts. So that we'll proceed from there. Okay. Only for this particular transformation, only for this particular slowly change dimension 1, because it is very, very basic things that you have to understand. So for the slowly changing dimension 2 is a bit complex, that I am going to take up after this the topic. So any questions till now? So what we have to do on all and everything? It's very straightforward. So what we are supposed to do on all and everything? Any questions, guys? Okay. So now we will take up a slowly changing dimension 2 actually we're going to take up. The slowly changing dimension is very, very important, and so we are going to use almost like how many transformations, table comparison, history preserving, and key generation transformation. So all these transformations in a single data flow. So that's the reason why the table comparison, the history preserving, and key generation are very, very important from the slowly changing dimension 2 implementation. So this is the data as usual. The file format will be the same. This is the file format. So obviously this is the data we already have here. Now we will see that history, how it is going to be maintained. Now we will also see that how actually the current is also going to be maintained, both. And you will also see that what is the validity of the date and during which period actually the customer has stayed in that particular location. So all these different information that you would be able to understand in the slowly changing dimension 2 actually. So now, but before that, as I mentioned previously, so we will have a recap of what is the slowly changing dimension, how it is going to be worked out. So this is what your source records, and these are all your target records. And as I mentioned previously, so in slowly changing dimension 0 and 1, the source structure is equal to the target structure. You don't have to create any extra columns here actually, if you observe clearly. But in the slowly changing dimension 0, we have the 4 columns here, but we have something called as another 4 columns have to be there in the target system. So for that particular reason, so what I'm trying to do is I'm trying to create a file format setup actually. I'm trying to create a file format setup there, and so that I can, form the structure in the target system, like valid from valid to the flag and SID. So all these things that I would like to have. So that's the reason why. So before performing then a slowly changing dimension 2, it is always recommended to verify in your target system whether you have this particular the setup is there or not. So that is what you have to understand here. So we have something called an employee ID, employee name, employee salary, employee address, valid from valid to flag and SID. So these are the important columns that needs to have, and you have to make sure that they all exist in the target system. Once these are all exist in the target system, then so you can go ahead with your the preserve of your history and update the current, or else update the or insert the update statements in each and everything that we can do that. So now go to the server and try to create the structure actually in the target system. The structure can be created in two ways in the target system. One thing is you can ask the DBA to create a SQL statement so that like he will create the table that he can do. Otherwise, as a workaround, rather than doing, so what I'm trying to do is I'm trying to create a structure there. Okay, just when I say structure, see here I will create a job SC underscore SCD underscore SCD structure underscore 6 AM IST, but this is not real time happens. Okay, so I will say that, so DF with this particular data flow I'm trying to create 6 AM IST. So I'm trying to create a structure, right? So for that, I will take up this as a source, and I would like to create a structure. So for that particular reason, so I would take up all these things in the target system as it is, and right click and make it like a new output column, insert below. It will be something like valid from, it should be date time, in the target system. Similarly, I also need to have insert below. I also need to have something called as valid to date time. So let's maintain the proper naming convention here. So valid from, so it says that it is the same name. So for that, initially you have to save it to 1. So after that, you have to save it, save this with from. Valid to, so valid from and valid to. After that, I also need to have a flag. So insert below, I will say like current flag. And that is a varchar. So similarly, I also need to have one more for the purpose of my SID. So target key, you can say that SID. That would be an integer value. So these are the 4 extra columns that I need to have in the target system. Okay, so currently, so everything would be nulls, or else you can also say that make it like an optional. So don't confuse yourself. I'm trying to create a structure in the target database. That's the only thing. All these things I should not do. I can do directly in the SQL the server. So if you tell to your the DBA guy, they will create it. You don't have to worry at all actually. I'm trying to create an STD table in the target system. That's it. Instead of going there and writing the query, I'm using the BODS for the same purpose also. STD2. Okay. So 8 records got loaded. That is fine, but all our the remaining fields are having the null values obviously because I didn't call anything. Now what I will do is I will go to the target. I mean to say to the SQL server, and I will truncate the table. I don't want that data with me. So for that particular reason, I will go to the SQL server here. And I will log in. And go to the respective database. What is our database? I forgot. So we can verify by logging into the data store here. What is our data store? Target underscore DB. Right click and edit. Okay, this is what our database is. Target underscore SQL server underscore DB. So target underscore so SQL server underscore DB. So double click here, or else you can expand here. So you can simply write. So what you can write here is truncate table. What is the table name? STD underscore 2. Table got truncated. Okay. If I go there in my the data services, if I refresh, I don't see any particular data, but I have a structure. See here, but I have a structure here. That is what my aim. Otherwise, you have to create a table. How you will create a table actually? With using the statement called create table. So you know all these things, right? So to create table, list of values or values into. So all these things that you have to perform. So I have to avoid that. So what I did is I just created a structure, and now the table is available with me. So I will just make it like permanent table here. Now I'm ready to proceed with the creation of a slowly changing dimension 2 data flow for our requirement. So JB underscore SED 2 underscore 6 AM IST. So data flow DF underscore SCD 2 underscore 6 AM IST. Now use the same file as your source. And what is your target? My target is this one. See here, this is very important comparison you have to make it. So we have a source, this is what your source, and this is what your target, okay? So initially, so you have records in the source system and you don't have records in the target system. So your table is empty. So now, as I mentioned previously, while doing an initial load itself, it has to generate all these valid to the flags and the SIDs. That is what your aim should be. So for that particular reason, I'm going to use the query transformation as usual. And you have to use a customer ID, customer name, contact name, address, and the city. And apart from that, because I will be knowing when I'm loading the records. I mean to say, I will be knowing what is the validity at least of that particular record. Because I'm loading now, the validity will start from now itself. So that's the reason why right click and I will create a new record, a new column here, insert below valid from, because I know from when it is valid, but I don't know to which it is valid, to which date actually it is valid. So I will be date and time, and because I'm loading now, I will be taking like this date. So you will get a doubt why you are taking this date, and again because like you are loading now. So it doesn't mandatory that you have to take a valid from as this date, because I don't have any date column coming from the source. If you have any date column coming from the source, then instead of using the valid from, you can use the same. That is not at all mandatory that you have to use the valid from always the date time. No, valid from that can be any field. I mean to say the date field is in source system. So where actually the date got loaded, or maybe on which the company was established, on which maybe the contact person has appointed. That can be anything. So in my scenario, I don't find any date field in the source system. So that's the reason why. So what I did is I have defined this particular the query transformation, and this particular query transformation is affecting the sysdate and all. It has to take care of the sysdate and all and everything. Now, having this particular knowledge, now we will use a table comparison here. The table comparison like this. The table comparison, we have to go for the table comparison. So connect source with the target. So table comparison, what you want to compare. But before that, as I mentioned previously, so we have to make sure that you have a primary key. We forgot to define a primary key earlier, so that is the main problem. Primary key, yes. We forgot the primary key. Primary key I have defined. Now I will create one more. I have to create one more table here. Slowly 1 and 2. I will execute the job here.
Venkat, how about the SID? You don't want to include into primary key?
Which one I didn't get you?
For the SID,
SID. Oh, SID. Oh, I will tell you that SID and all and everything. Okay. So I'm trying to set up the table here once. Let us see what are the records we have. Why it is giving the so select start from.
there is one record which got like duplicate, I think.
Oh, if it doesn't have a duplicate, then yeah, it will give an error message. Okay, again it got a failure. Okay, not a problem. See here, it is always in the proceed state, but not in what do you call as stop state. What is the record? It is in duplicate. Oh, it should be 1, right? Okay, that is fine. So now I will go to the source and remove the duplicacy. This is also a practical problem. So in case of these type of issues, we will inform to the customer, and customer has to manually go there and change it. Okay, see here, even if it is having P1, why it is getting loaded as P? Any reasons why it is? Can you tell me? Can you guess?
The length?
Yes, please.
Is it because of the length?
Right, because of the length it seems to be. What is that primary key? I have given 5. But what we have here, 5 only, it has taken. Oh, it has a 6 actually. See? Initially we have defined 5, after that we have added 1 more. So that's the reason why it is a problem here. So in order to rectify that problem, you have to go to the file format, right click here, and you have to edit here, and instead of customer ID 5, you have to say 6, or maybe if you feel that if more will be coming into your way, you can also define 25, something like that. Okay, so once you have changed, you can see that automatically the customer varchar 25 is automatically changed here. Now if you run the job, the data will get loaded. Right. Why there is a problem? Can you tell me once again? Because there is a problem in here. We have defined 25, so that is fine. But what about in the query transformation? See here, it is still 5. We have to change it to 25. Now execute. So each and every level, so you have to verify it. So now it will be executed successfully. Now I will go there in the SQL Server. Now I will truncate the table. Okay, so I should not see any records here. Something like this. Okay, if required, what I will do is I will also maintain SID also my primary key. Let us take an example. Then execute and see whether this time how it will go. Can you guess why it is got failed here this time? This time it got a failure because we are trying to define a primary key. Okay, so that is the main reason here. So rather than doing that, let us verify whether we can do it from this location or not. I'm trying to refresh here, underscore. So these are the columns here. See here, we have the customer ID and the SID. So it has created a structure. So I'm fine with that because I need only a structure. And the reason why it is not getting loaded is whenever we are trying to make it like the primary key, it is automatically saying that it should not be a null. But here, because we don't have any records in the source, obviously it is trying to update or insert a null value into an SID. So that's the reason why it is giving a problem. So we are not at all related with that problem. So don't worry at all. So we have to understand whether we are able to create a structure or not. Once you are able to create a structure, right click and execute and import the table, make it like permanent. Then my the source records would be, my target would be something like SCD underscore 2. So where is that? Yes, this is what my target. Make it like target. See here. This is what my source and this is what my target. Now, if I try to compare the source with the target, go to the table comparison. We will see each and every option here almost. In the table comparison, so we have to compare with the target, SCD underscore 12, generated key column. The SID will become my generated key column. And what is my primary key? My primary key is customer ID. So here I have to change it like 25 because we have changed in the file format. Right click and define as a primary key. And in the table comparison, compare the primary key, and after that, what do you want to, once the customer is exists in the source or target, what do you want to compare? I want to compare my city, something like that. Okay, once this is completed, now please have a history preserving transformation, something like this. The table comparison. Now we are talking about a history preserving transformation. So history preserving transformation. See here in the history preserving transformation, the history preserving transformation will ask you what is the valid from here. See here, this is what my valid from. And what is valid to here? This is what my valid to. And if it is a valid to, you are going to create a valid to value. That value will be generated by the history preserving. The valid to value would be something like 9,012.31. So if you want to have your own value as an active, as a valid to, maybe some customers say that I don't want to use the 9,000 as my active record. Maybe I have to use like maybe 100 years down from now, something like 2115 years, something like that. You can do that. So similarly, the current flag would be current flag record. And initially, you want to set it to maybe Y. So after that, you can set it to N. That we can do that. And after that, what you want to compare here? You want to compare city, drag and drop. You want to preserve the city actually, frankly speaking, preserve. After that, so please drag and drop the key generation transformation.
Can you go back once?
Yes, please.
Into the history. So right now here, right? So we are this is the record which we are preserving the record. That means the previous record, right?
No. When I say preserve, whatever the information that you want to preserve is the city. Getting my point?
Yeah.
If city, so, yeah, if city is changed, please, have the previous record and also please insert the new record. That is what we're trying to do.
So in history preserve, I think like we are storing the previous one. We are trying to store the values of the previous record. Is that right?
Previous record and also the new record also. Both. Okay, don't worry about that.
Yeah.
First we have a first run of this particular job, okay? Then we will try to change it. Then you will see that what's happening and all.
Sure.
But please keep your eye on this particular new record section, okay? Valid to section of the result. Similarly, the current flag section, okay?
Yeah.
Then you will understand much better. So once these all are completed, then you can make use of a key generation transformation. As I mentioned, key generation transformation, it is responsible to generate a keys. Like row generation, how we have generated multiple integer values. In a similar fashion, you can also give that. So for this, for which field actually you have to generate a primary key. So you have to generate an SID. That has to be mentioned here. For SID, you have to mention, and the value should be incremented by 1 or 2 or 3. It's all up to you. Maybe by 100, it's all up to you. Maybe for now, I'm giving you only 1. Load it into the target system. See here, in the table comparison, you are comparing source with the target, and you are loading finally into the target itself. That is what actually happens. Now I will proceed and execute the first load of it. Currently, I don't have any records in the target. That is what we have to understand now. I have a doubt. Earlier we have changed it, right? Not at all. So now we will try to understand the results now and try to identify now. This is a source and this is a target. While loading into the target, so please observe carefully here. This is the valid from value that I have populated in the query transformation using sysdate actually. Okay. And this is the valid to is a value populated by the history preserving transformation. And similarly, I have mentioned as everything is Y, current flag Y, because these are all active. Why these are all active? Can anybody answer my question?
Still, it doesn't have any previous record.
Right, it doesn't have a previous record. And you can also say that where the valid to is 9000, all the records are active. That is one thing. And you can also say that where the current flag is Y, also current record. Am I correct? Guys, especially the guys, Don, are you getting my point? What I mean to say here? Don, Karen, Mike, Meena, so are you getting my point? What I mean to say here? Okay, great. Okay, thank you. So now I will go ahead and change the record in the source. Now see the change. Let us see here. Right, the initial load is always current and the valid. Right, valid to. Now I will insert one more. Let us see here. Here I have inserted one and I am updating one. Let us see. What I am updating for VLF NP. Let us take an example that Bangalore.
Ninth and 10th and same.
9th and 10th are same. Right. Okay, we will delete this and change the above. Okay. So now I've changed it. Now I will execute the job and see what actually happens here. So please observe carefully. See here, earlier the guy is in Hyderabad and at 7:59, and I have changed the location to Bangalore at 8:03 minutes. Okay. Now what is the idea here is the end of this particular record, as Venkat is in Hyderabad, is changed when the Venkat has changed to Bangalore. So the end validity of the record, this is becomes my valid sum for the next record. Getting my point? What I mean to say here? That will become N and this will becomes Y. So similarly, I have inserted one more, I guess, right? This is one and this is the second one. So getting my point? What I mean to say here? What we're trying to achieve here, guys? The validity end for one record will becomes the validity from, and wherever we have a new records, so that will becomes N. So this is how actually we are going to make the changes. So getting my point? What I mean to say here, guys? So what we're trying to achieve here? So any questions in that? So the key here is only the part of history preserving, like this. History preserving is equal to map operation. Map operation also going to does the same. What it is going to do here in the history preserving? It is going to update some records. It is going to insert some records. What it is going to update? It is going to update the respective the city values and the valid from and valid to and the respective SIDs and the target keys. So are you getting my point? This is a very, very important point, so that you are going to use it in your the projects most of your times. Any questions, guys?
Yeah, question, Venkat. So for every SID type 2, so we should have like valid data from and to as well as flag.
Right. Because because in the history preserving transformation, you have to supply all these things. Getting my point? That is a parameter that needs to be passed for the history preserving transformation if you want to preserve the history along with the CDC. This is called as a CDC actually. Getting my point? What I mean to say?
Yeah,
change data capture.
Right? Yeah,
this is a slowly changing type 2. No. Mainly we have two types of CDCs as I mentioned previously. We have something called as source based CDC and we have something called as target based CDC. Whatever the CDCs that we have discussed in today's session, like storage change dimension 0, 1 and 2, everything comes under the category called target based CDC. I mean to say everything you are bringing into the BODS, then you are comparing it. Getting my point? What I meant to say here? That's the reason why it is called as a target based CDC. There is one more concept that is called as a source based CDC. Source based CDC is nothing but, let us take an example that you are loading a 10,000 records as an initial load today, and tomorrow you are getting only 100 records as a delta from the source system. So what is your best approach? Just load 100 into the target system, or else in order to understand what are all got changed in the source, you will compare all the 10,000 plus 100 in the source with the 10,000 in the target. Which one is best approach? So getting my point, what I'm asking here, let us take an example that we have a 10,000 records in the source and we have a 10,000 records in the target initial load. So in the source we are getting 100 records unloading, and that has to be loaded into the target system. Instead of in order to loading all the 100 records in the target system, which one is the best approach? That's what actually we have to understand here. When I say best approach, whether the comparing 100 records only coming from the source to the target is the best approach, or comparing 10,000 plus 100 in the source with that 10,000 in the target system, which one is better performance technique?
Yeah, obviously, like the 100 records one.
Right. So whatever the scenario that we have discussed till now, so like table comparison, map operation and all and everything.
Yeah.
Just try to make. Yeah.
My question was different, Venkat. Okay.
No, that is fine. So I didn't. It is different altogether that I'm trying to discuss. Okay.
Okay.
Yeah.
Okay.
Tell me what is your question.
Yeah, the question is like in the history preserving, I see the options for date columns as well as current flag, right?
Right.
So for type 2, STD type 2, usually like it can be maintained only with the dates, or it can be maintained only with the flag, either one. Because like you can identify a record with the surrogate key plus with its dates, or surrogate key plus this flag.
Right. What you said is right.
Yeah, here we are doing like both. So is it mandatory we do it, or?
Okay, got your point. So whenever you do a history preserving transformation, these are mandatory. Getting my point? What I mean to say?
Okay.
Yeah, that's what I'm trying to tell you. So whenever you say history preserving transformation, this is the way you have to do that. Okay. So if you don't want to, yeah, that's what my answer. But yeah, so let's come back to the topic what we have discussed: source-based CDC and target-based CDC. When I say source-based CDC, yes, please.
Venkat, I have a question here. So in the compare columns,
Yes, please.
if we have multiple columns, even we don't know, I mean, how will you come to know that the changes are, in the multiple column or only one column?
Okay, great. So when you say, let us take an example that when you're talking about multiple columns, so obviously you will be defining some primary keys, right? So obviously you will make sure that there are no duplicates. Am I correct? Even in the compare column also, because you are maintaining the primary keys, so definitely you don't have any duplicates. Am I correct? What I mean to say? In case, if you have any duplicates, let us take an example. That won't be the case in general. And even in my career, I didn't see that comparison column is having a duplicate. But if you have, see here, if you have duplicates, then you can say that input contains duplicate keys. Then let us take an example that with that primary key, if you have more than one column in the target system, more than one record in the target system, then randomly it will pick either of the two. Getting my point? What I mean to say here? If you have two records from the comparison field where these two records are duplicates, then randomly it will pick one record. That's it. It is not going to pick everything. It is going to pick only one record and it is going to perform the rest of the operations. So getting my point? What I mean to say here? So it all depends upon how many are equal. How many are equal? So if it is an equal, then it will take one. Okay, but you have to say that input contains duplicate keys. Once you check this checkbox, then only the BODS says that okay, it has two duplicates, then I have to take only one. If you don't check this checkbox, if you have a duplicate records in your source system, let us take an example. Okay, in that case, duplicate records in the comparison table. In that case, it will take two records into comparison. Getting my point? What I meant to say? It will compare with the two records, then it will perform the operation on the two records. That's the reason why if you feel that if you have a duplicate record in the target system, check this checkbox. Then it will take only one on the fly. And it won't be a problem for you. That is one thing you have to understand. And come back to the options here. Row by row, cast comparison, and the selected forward input. In general, if you want to compare less number of records with the more number of records or vice versa, normally these methods will be used. But in general, out of all, row by row method would be the best option. In a lot of my projects, what we have worked, I have worked on the row by row. Row by row won't take much time. When I say cast, yeah, somebody is asking.
How does it work, Venkat?
When I say row by row, what actually happens here is, so it will take a source record and it will take a target record. Okay. So when I say source record, so it will bring one record from the source, it will bring one record from the target, and it will compare. Getting my point? That will be taken care, and each and every comparison will be done by the nanoseconds. You don't have to worry at all. When I say cached comparison, if you have 23 billions of records in the target system, it has to first bring every record into the cache, BODS cache. Then similarly bring everything from the source system. Then compare. So getting my point, what I meant to say? That is what actually happens by row and the cached comparison. The sorted input, it is going to sorted input. So it is going to sort the input, what you call as primary key. It is going to sort the primary key, then it will compare. Okay. So that is a basic difference. So when it is used or not, it all depends upon the requirement. By default, row by row, you don't have to switch to the cast comparison table or the sort input. You don't see much difference between other two, but the row by row and the cast comparison will differ a lot. You see a lot of performance enhancement of the row by row when compared to the cast input and all. Okay. In order to bring everything into the cache itself, it will take long hours. Okay, so that's the reason why row by row is the best option in all means. Similarly, when I say run a separate process, so as I mentioned previously in the first session or second session, BODS can also do some performance optimization technique. So whenever I say performance optimization technique, all these table comparisons, all these group by, order by, everything will be called as performance degrade technique. Okay, these will eat away a lot of your resources on your BODS system. Because it will eat away a lot of resources on your BODS system, so in order to mitigate that problem, so in BODS we have one option. The option is please assign some resources. So please assign some resources to the BODS. I mean to say the operations. What are the operations? The table comparison operation here. The table comparison operation will perform a performance degrade technique here. So in order to mitigate that, so we are assigning one more process to the table comparison so that it will parallelly doing all the operations. So that is what actually called as a run a separate process. But in general, we are not going to use these options, because if you say like run a separate process, there will be multiple threads will go to the database. But you also need to make sure that whether your database is having those many number of named pipelines or not. So that problem also will be there. So you have to check with your database administrators if you have to use this run a separate process. So in my career, like once or twice, we have ran this particular table comparison with run a separate process. But what actually happens there is it is going to divide the job. So maybe we will try to run it as a separate process, and we will execute it. Let us see what actually happens here. See here, 1, 2, 3, 4. So it has divided actually the job into 4. Getting my point what I mean to say? The data flow, they have divided these data flows into 4 sub-data flows. Okay? Once they have divided, once they have processed each and every job. See here like this. After that, sub-data flows completed, something like that. So this is how actually, so the usage of the table comparison will be there. So you have to understand that point.
So can we define that value to divide into 4 or 8 or like that?
By default, it will be 4 in general, but we don't have any option to define it. You don't have any what you call as divide it, or you don't have to enhance it. So by default, in general, it will be 4. I don't see any option to have it. So you can also say, like, let us take an example that.
Is it something
degree
of parallelism something?
No, degree of parallelism is different actually. No. Degree of parallelism, yeah, so you can say that the same thing. Given the degree of parallelism also, it is going to divide the job. See, let us take an example. If I go to the data flow and the properties, okay, so here we have degree of parallelism is how much? Default, right? So if I execute this particular job, let us take an example. How many it will take us? So I have mentioned there the degree of what is that? Yeah, here we don't have a run as separate process. If I go to here in the query transformation, here we have something called as a run as separate process. If you are doing anything, order by join, if you are doing anything, then these will take into effect. Okay, but the degree of parallelism default would be nothing in general. So that's the reason, guys, if you have to use all these performance enhancement technique, your database also should allow all these named piping lines, because only 4 or 5 or 7 sessions will directly hit the database, because one data flow is divided into 4 data flows. When I say 4 data flows, 4 connections, 4 data store connections, 4 hits to the database at the same time. It all depends upon how your database, because database is not only depends on your BODS. Maybe some other jobs are also there. Maybe some other applications are also there, depending on the database. So all these things are very much important whenever we are going to discuss this the parameters.
One question, Venkat.
Yes, please.
Yeah, in this SCD2, you have given run a separate process for only one transform, right? Here it is showing for multiple, like it says multiple number of times, saying like 1, 2, 3, 4, again 1, 2, 3, 4, like that. Any reason like that?
Yes, that's what I'm saying. Whenever I say data flow is divided into 4, it says that 1 of 1 data flow, 1 of 2 data flow, 1 of 3, 1 of 4 data flow, something like that. Getting my point? What I meant to say? In our entire SCD job, we have only 1 data flow, right? Whenever I say 1 data flow, so what actually happens? This entire data flow is divided into 4, something like 1, 2, 3.
Oh, it's like entire data flow.
4.
Yeah,
yes, entire data flow will get called as sub data flow here. Okay, 1, 2, 3, 4. Okay, it will be 1 of 1, 1 of 2, 1 of 3, 1 of 4, something like that.
Right. I thought like you have given the option. Where do you give this option? Like in only one transform, right? In this,
Yeah. If you go to the table comparison, you see the option here. If you go to,
so if you give in one transform, it will uplift for the entire data flow.
yes, because if you go to the table comparison has to compare it, right? Wherever it requires, wherever it degrades the performance, where you see an option.
Okay.
Getting my point?
Yeah.
Yeah, even in the query transformation also, the group by, order by, join, distinct. So these will take away a lot of your resources, right? So that's the reason why. That's the reason why. So you have to identify that. So wherever it is required, you can give that. Otherwise, you don't have to give. Okay.
Okay.
So this is also one of the performance the tuning technique. Okay. And also there is one more performance tuning technique. Like if you are trying to write any particular what do you call as any join condition, any filter, just try to write the join condition here itself or filter in the first transform. Getting my point? What I mean to say? Let us take an example that if you remember, whenever we have discussed a case transformation, what we have discussed, we have written like 4 or 5 different query transformations. It is always recommended if you are writing the query transformations like this. If you are using or 2-3 query transformations like this, okay, it is better to write a condition here rather than writing the condition here. So getting my point? What I meant to say here? That is also one of the performance tuning technique. If you write a join condition here or filter here, all the calculations will be pushed down to the database automatically. So getting my point? What I meant to say? So that is also one of the performance tuning technique. So in fact, I have one document. So I will forward with you guys. So so where you will have a performance optimization technique will be there in special. So so where you can see that. Okay. So performance optimization techniques, what you can follow and all. Okay. So that is one thing. So with this particular the topic, we have completed the slowly changing dimension 2 on 1 and 0. Okay. So this is the part of your entire data warehousing system. And also the slowly changing dimension 2, the implementation is very, very easy when compared to other ETL tools in the market like Informatica, like your SAP BW. When compared to all, so the implementation of especially the slowly changing dimension is very easy in the BODS. Okay. Yeah.
I have one question here. So in the in the key generation, so usually I mean like if it is database, right? So let's say for example Oracle, we have something called DB sequence. Is there something like we can give in the key generation transform?
What is meant by DB sequence? I mean to say, and I mean to say like DB will generate a sequence of numbers, something like that.
The increment value can be given here itself, but still we need to. It's just an object in the database. That's a DB sequence you call sequence. So we'll have to configure the Oracle or any database because like for every database there's something called like sequence. That's surrogate key they'll use. So here do we have that kind of option?
A very good point you have raised it. So let us take an example. If you have any particular field name, if you have, do you have any field name, something like that in the database where you can call something like that? So getting my point, what I meant to say?
No. Okay. What is that?
When you say like database sequence, whether it is a column?
Yeah.
In the database?
Not it's a column. It's like a table. It is a object. It's
okay, got your
object.
point.
Yeah.
Got it. See here. So if you want to have, you can give it. Not a problem here. But the problem here is, see, whatever the table, whatever the field you have here, whatever the the table you have into which you are trying to load it, you have to give only that particular field. Getting my point? What I mean to say here?
Yeah. So where this is
in the table comparison, what we are trying to compare here? We are trying to compare with the target. In the target, we have to make sure that SID field is there. That SID field is generated with a ID.
Okay.
With 1. But rather than doing this also, we can also do one more point. Without using this particular, the key generation, you can also place one more that is called as the query transformation. Also, you can do that. If you see in query transformation, so we have the something called as functions. In the functions, we can have something called as key generation. See here?
Yeah.
Getting my point? So what you can do is, you can use a query transformation instead of key generation transformation. That is also we can do that. Okay? That is one thing. But I don't think so we have an option to directly call that data, the sequence column here or table here. Okay? We can call it, but the problem here is how, so we have to, place those values into SID is also big point here, because we are dealing with the target structure. Along with that, at a given point of time, we are adding only one value at a time. So getting my point, what I mean to say here? So these are all, linked with each other. So that's what we have to understand.
Okay. So there are only 3 options to give there. Like can you open the key generation transformer?
Right. If you open the key generation, even it won't allow to pass any global variables also. See here, we don't see any problem. Okay. Yeah. At least here you can give some values, like what is the value that you want to give, at least the increment value, whether it is 1 or maybe 1000, maybe, where you can declare a global variable. Maybe while running the job, you can pass your own value in the global variable increment, something like that. Okay. So that point is there. Okay. So that is the thing. So any questions, guys? So this is very, very important, and also I'm thinking, if time permits, so during our course completion, so I would like to take 1 or 2 examples more on this entire the table comparison and the map operation. So where we can avoid using the table comparison, where it is mandatory for us to using the table comparison and all, if time permits, because whatever the information that I would like to give, I already given for the table comparison and all. But if we have a time and if we are able to complete in time, so what we can do is we can also see 2 or 3 examples more on the table comparison and the map operation, where we have to avoid instead of using the table comparison, what are the other options we have. So all these things that we will see. Okay.
So in this, we have not used map CDC operation.
Right. The map CDC operation is called as a source-based CDC.
Okay.
As I mentioned, guys, previously, see here in transformations, we have something called as map CDC. See, map CDC is nothing but, earlier I have told you an example, where the example is, if whatever the table comparison we are doing, we are taking 10,000 plus 100 into the BODS, then we are comparing with 10,000 records in the target system. That is a target-based CDC that we have been doing all these minutes. Okay. So, but if you want to get only 100 records in the source system, you have to use a map CDC operation. Okay. So the map CDC operation is one of the performance enhancement technique, but the problem there is you have to configure a lot in the source system. I mean to say you have to define. So maybe I can give you some brief idea on it. So because it is practically not possible in the demo systems, that's the reason why I won't be able to show you on the map CDC operation. But the main point here is you have to define something called as a replication agent. You have to define in the source system. And after that, you also need to define something called as the markers in the source system, subscribers in the source system. So all these things have to be defined in the source system. So for each and every record or cut record, so I mean to say like till yesterday the records got loaded. Till date, it will identify one marker. So whenever we are trying to load today, it will take that marker as a reference, then it will load the rest of the things to the BODS to compare. So that is what actually happens with this slowly changing, with this map CDC operation. Okay. So I will find out, so I have a document for that event, map CDC operation, the detailed document. So CDC. Once you have a map CDC, once that process is set up in your source system, you don't have to do anything. You have to simply drag and drop the map CDC, something like this. That's it. You have to drag and drop the map CDC. So this particular the things, like you have to see that what is the sequencing column. You have to maintain one sequencing column, something like that. Sequencing column means something like, as you have mentioned, what you call as database sequence. So I think you have referred earlier, right, Raju? Database sequence.
Yeah, yeah.
That database sequence column that can be maintained in the existing table itself, not as a separate object. Okay, that sequencing column should be there, and after that sequencing column you have to say that row operation column. So it will give you some flags, right? Insert or update. It will give you something like, getting my point? What I meant to say here, it will write the flags. So all these things will be, like possible in this particular map CDC. It will give you only those 100 records. This is called as a source based CDC. Getting my point? But it is not very regularly used. But normally we will make use of a table comparison and the map operation, because this requires some configuration in the database level. What is the configuration and all and everything, that I will send it to you guys. Okay.
So if you are using this map CDC operation, we don't have to use the table comparison.
Yes, you're right. Absolutely. Yes. Any questions, guys? So please.
Yeah, you said like you'll be providing document on map CDC operation, and there is one more document you said you will provide.
Performance optimization. Yes. Two documents. Yes.